Hey, hope your reading is going well as we continue through this chapter looking at, looking at perception in general, focusing mostly on visual perception. But, I should say at the outset, the reason for that is a lot of the things we want to talk about along that path you could do again with auditory perception. You could do it with smell, touch, vision, everything. The textbook will talk to you about a lot of those other senses and give you, dare I say, a taste of some of that. We're focusing mostly on vision so that we can tell that overall story, and because it's really the main sensory system for us. So if we're going to pick one, it's the one to pick. So, as we've been sort of talking things through, we've talked about sensation, that very first, the energy coming in and transduction, literally the physical energy of the real world becoming a neural signal. And then right from the retina, it's already a neural signal at the retina. And as it's coming in and working its way to the primary visual cortex, it's already being processed. We already have those top-down influences coming to bear. Once it gets to the primary visual cortex, we know that there are these feature detectors that look for certain features and seem to kind of rebuild what we're seeing in our mind by connecting all of those features together in some way. So it's kind of like the external world gets rebuilt, but it's rebuilt not just based on the energy coming from the external world, but also based on our previous experiences that reorganizes that energy. So hopefully that all makes sense. Once it's in the primary visual cortex, it then goes to association cortex. And remember that what pathway. This is kind of what we're going to talk about in a little bit more detail here, because really the end goal of perception, and in fact almost the thing we are primarily aware of, it's like everything else happens so fast. When we look at the world, we see objects. We recognize what it is we're looking at. Almost everything you look around, if you just take time to look around your world, almost everything you see is something that makes sense to you, something you recognize as an object. If you see something that you don't recognize as an object, you often want to go check it out. Like, what is that thing? It's like our brain wants to know what's out there. And so, how does it do that? How does it recognize an object? Okay, and that's going to be the focus of this little mini lecture. So, just to start off with, here's a bunch of objects. Actually, I'm not really sure what this one is down here. I was about to say, we can recognize these things really easily. Most of them we can. This is an old school set of headphones, back before, wireless AirPods and stuff like that. Maybe you won't recognize this. This is a projection device to project a computer thing onto a screen. But for the most part, you can look around. I mean, these are hard to read, so we know they're bottles of something. We're not really sure what. This could be toothpaste or glue or something. Who knows? But generally speaking, we can look at these things and recognize them, even when some of them look kind of the same. They seem different to us. Even two things that are both the same. They are both the same. These are both cows, I think. And we can simultaneously sort of recognize them as a class of item, a cow, and also as a sort of individual of that item, a cow that has very specific characteristics. So quickly we look around the world and we just know what it is we're seeing. And so this has been a challenge for psychologists too, to try to understand how the brain does that. It's especially interesting, of course, because if I just take a common object, I don't know what common object I'll take. I guess I'll use this. This isn't that common, but it's a microphone, and you would probably recognize it as a microphone. But the interesting thing is you don't just recognize it as a microphone if it's like that. You also recognize it like this, and maybe like this, at least once you know it. I mean, heck, you can even see it like that and potentially recognize it, or maybe like that. If I'm looking for my microphone and this was knocked over somewhere, I might see that and go, oh yeah, that's it. It's not just that we recognize it, we recognize it from almost every angle, or all sorts of different angles. And so we can present it to us. It can be presented to our eyes in so many different ways, cause that stimulation, and yet we're able to recognize what it is. It's truly amazing. How does it happen? So as psychologists began thinking about this, they started with what they thought was the most reasonable approach, We know from the work of Hubel and Wiesel that was discussed in the textbook that there are so-called feature detectors in V1, or primary occipital cortex. It's sometimes called V1, vision 1, the first layer of vision. And so we know that there are certain detectors just waiting for a line of a certain orientation. And if that line is there at that spot of our retina, then those cells fire. If anything else is there, they don't. And so the brain is almost deconstructing everything into these primary features. And the idea is, it's detecting what primary features are out there. They are all becoming active, and then something else glues those features back together in our mind to produce the object. And so maybe it's at that feature level. Maybe we can define objects according to features, and an object that has certain features we recognize as something. As I'm kind of highlighting here, it turns out this doesn't quite work. Let me ask you right now, what are the features of a chair? If I asked you to define a chair in terms of visual features, you probably already run into some trouble. We can define what we call the prototypical chair. If we imagine, what is that image in our mind when we think chair? Oh, well, that has a flat bottom, it has a back, it has 4 legs, and probably maybe a cushion for your butt if it's a comfy chair. That is our prototypical chair. But which of those features are critical? Which of those features make it a chair? Does it have to have a backrest? Well, a lot of chairs don't have backrests. Does it have to have 4 legs? Well, some have 3 legs. Some don't really have legs at all. Does it have to have a flat part to sit on? Well, it seems like it should have to have a flat part to sit on, right? But that doesn't really define a chair, because tables have flat parts. All sorts of things have flat parts. How do we define a chair? Well, Wikipedia. We can always go to Wikipedia. One of the basic pieces of furniture, a chair, is a type of seat. That doesn't help us a whole lot. Its primary features are, here we go, 2 pieces of a durable material attached as back and seat to one another at a 90-degree or similar angle, with usually the 4 corners of the horizontal seat attached in turn to 4 legs, or other parts of the seat's underside attached to 3 legs, or to a shaft about which a 4-arm turnstile or rollers can turn, strong enough to support the weight of a person who sits on the seat, usually wide and broad enough to hold the lower body from the buttocks almost to the knees, and leans against the vertical back, usually high and wide enough to support the back to the shoulder blades. The legs are typically high enough. Okay, so you see an attempt to define a chair. And with all that said, I'm going to show you a picture, but let me just show you what I sit on while I talk to you guys every day. And then I'll show you a picture of it, but here it is. You ready? There you go. Wow. There it is. Or there it is. That's my chair. It's a yoga ball under my butt, stuck onto some plastic thing that has wheels underneath that roll on it. It's still a chair. If you walk into my office and you see that, I can tell you from years of experience, people who did walk into my office when I had an office knew what to do with that thing. They knew that was something to sit on. They knew it was a chair. They might do a double take and say, "What? Ooh, wow, that's a weird chair." They might say that, but they recognize it as a chair. So it's not just about something having specific features. It's more complicated than that. What do we now think is going on? It's more like what we call fuzzy matches. So like even this thing that I show you here, if I asked you what that was, you'd say it's a dog. You might say it's an odd dog. You might say it's a 6-legged dog in order to kind of differentiate it from most other dogs. You might say it's some sort of freakish nuclear reactor dog. Who knows? But it's still a dog. And this is the point. The brain doesn't need to have a complete match between what you're currently seeing and something it knows. It seems to rely on something we call fuzzy matches. And that when we combine it with prototype theory, so just walking you through here. So I already introduced you to the concept of the prototypical chair. So let's talk prototypes for a second. For almost anything, tables, chairs, people, books, almost any noun, dogs, anything you can imagine, we usually see a big variety of them in the world, and certain variants are much more common than others. So let's imagine birds, for example. If we think of birds, we see a whole lot of, here we see anything from seagulls to robins to, we have some cardinals, we have some blue jays that are around. I saw a bald eagle this morning, as a matter of fact, right along Lake Ontario. First time I ever saw one. It's pretty cool. And so we have all these birds around us, but certain are really common, like the sparrows and the robins and the grackles, and they're pretty common around us. And so the idea is just this: the brain has seen a whole bunch of birds, and out of all of those birds, it has built the average bird. Somewhere in your mind is this concept of what your average bird looks like. And it probably looks something like a robin, something sort of like that, but maybe not exactly like a robin, because it's really literally an average of a whole bunch of different birds. And so now the idea is you're out walking and you see something on the fence over there. And you look at it and you start to get information about it, including some of the features. And what that does is it kind of connects with all of our prototypes of what that could be. So could that be a squirrel? We have a prototypical squirrel somewhere in our mind. We have a prototypical bird. We have a prototypical rat. We have a prototypical owl. No? Well, yeah, but that would mess up with my bird thing. So let's just stick with the bird. We have a prototypical cat. And so the idea is when we're seeing that thing, it's coming in and being matched to all these prototypes. And whichever one it matches with most closely, that's what we recognize this thing as. So as long as that bird type thing is more bird-like than it is rat-like or cat-like or any other prototype we might have, then we see it as a bird. So we can see a penguin as a bird because a penguin is more like our average bird than it is like our average cat, for example. That's the claim, is that is what the brain is using, that it's constantly building up these prototypes as it gets to know things, and that it's doing some sort of fuzzy match to prototypes. And it does so really, really quickly and generally accurately. We don't usually misrecognize things. We usually recognize them with high degrees of accuracy. In fact, if we go all the way back to that picture I showed you of the fireworks over Niagara Falls, that is what we usually see when we look at something. Fireworks over Niagara Falls, recognized things. We don't see all that processing that happened to get us there. We go right to recognition, and we think this is the process that underlies that. So I wanted to throw that in there. I didn't see that clearly laid out in the textbook. So there you go. Fuzzy matches. Odd dogs. See you in the next one. Bye-bye.